Hi everyone. You might have seen a beam of sunlight when it enters a room through a narrow opening or a hole. You may have also seen beams of light from the headlamps of scooters, cars, and engines of trains. Similarly, a beam of light can be seen from a torch. Some of you may have seen a beam of searchlight from a lighthouse or from an airport tower also. What do these experiences suggest? Yes, we know that the light moves in a, otherwise, the light travels in a straight line. So, here we are going to study about the light. In class 6, you have learned that the light travels in a straight line. In that activity, we can take a straight pipe and then look through the pipe. You can see the candle first through a straight pipe and then through a bent pipe. Why was the candle flame not able to see through the bent pipe? Because the light travels along the straight line. How can we change the path of light? Do you know what happens when light falls on a polished or shiny surface? Yes. One way to change the direction of light is to let it fall on a shiny surface. For example, a shiny stainless steel plate or shiny steel spoon can change the direction of light. The surface of the water can also act like a mirror and change the path of light. Have you ever seen the reflection of trees or buildings in water? So, any polished or shiny surface can act as a mirror. You have learned in class 6 that a mirror changes the direction of light that falls on it. This change of direction by a mirror is called reflection of light. Now, here we are going to perform a similar activity. Take a torch, cover its glass with a chart paper, which has three narrow slits as shown in the figure. Spread the sheet of chart paper on a smooth wooden board. Fix a plane mirror strip vertically on a chart paper. Now direct the beam of light on the mirror from the torch with the slits. Place the torch in such a way that its light is seen along the chart paper on the board. Now adjust its position so that the light from the torch strikes the plane mirror at an angle. Does the mirror change the direction of light falls on it? Now move the torch light slightly to either side. Do you find any change in the direction of reflected light? This activity shows how light gets reflected from a plane mirror. Let us play around the images formed in mirrors and know a little more about them. Place a lighted candle in front of a plane mirror. Try to see the flame of the candle in the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror. The candle itself is the object. Here, the candle it's an object, and if you can see something on the mirror, that is the image. Now move the candle to different positions in front of the mirror. Observe the image in each case. Was the image upright in each case? Did the flame appear on top of the candle as in the object? Such an image is called erect image. If the image is as the object which is kept erect, then the image also erect. Now we have studied now the image formed by the plane mirror is of the same size of the object. Now you see in this, take a chessboard. If a chessboard is not available, draw on a chart paper 64 squares of equal size. Draw a thick line in the middle of the paper. Fix the plane mirror vertically on this line. Place any small object like pencil sharpener at the boundary of the third square, counting from the mirror. Note the position of the image. Now shift the object to the boundary of the fourth square. Again note the position of the image. Did you find any relation between the distance of the image from the mirror and that of the object in front of you? You will find that the image is at the same distance behind the mirror as the object in front of the mirror. So, here we have studied in the plane mirror, the image is formed is of the same size. Number 2, the distance between the mirror and the object is equal to the mirror and the image. Now, third point you are going to study about is the right-left inversion, otherwise the lateral inversion. Stand in front of the plane mirror and look at your image. Raise your left hand. Which hand does your image raise? Now touch your right ear. Which ear does your hand touch in your image? Observe carefully. You will find that in the mirror, the right appears left and the left appears right. Note that only sides are interchanged. The image does not appear upside down. So, we can say the properties of the image formed on the plane mirror is the image formed by a plane mirror appears behind the mirror but cannot be obtained on the screen in the either case. The image formed by a plane mirror is laterally inverted. And in a plane mirror, the image is formed at the same distance behind the mirror as that of the object in front of it. So now let's study about the spherical mirrors. You take a stainless steel spoon, bring the outer side of the spoon near your face and look into it. Do you see your image in it? Is this image different from what you see in a plane mirror? Is this image erect? Is the size of the image same, small or larger? Now look at your image using the inner side of the spoon. This time you may find that your image is erect and larger in size. If you increase the distance of the spoon from your face, you may see your image inverted. You can also compare the image of your pen or pencil instead of your face. So the curved shining surface of spoon acts as a mirror. The most common example of curved mirror is a spherical mirror. If the reflecting surface of the spherical mirror is concave, it is called the concave mirror. If the reflecting surface of the surface is convex, then it is a convex mirror. So, how you can find out the concave and the convex mirror? Take a rubber ball and cut a portion of it with a knife or a backsaw blade. The inner surface of the cut ball is called concave and the outer surface is called the convex. So here when you see here, some image is formed. An image formed on a screen is called a real image, and the image which cannot be formed on a screen is called the virtual image. Now, let's see about the concave mirror, the image formed by a concave mirror. So, concave mirrors are used Fix a concave mirror to a stand and place it on the table. Paste a piece of white paper on cardboard sheet. Keep a lighted candle on the table at the distance of about 40 centimeter from the mirror. Try to obtain the image of the flame on the screen. Now move the candle towards the mirror and place it at a different distance from it. So in each case, try to obtain the image on the screen. So when lighted candle is placed very close to the mirror, its image could not be obtained on the screen. When the object is placed far away from the concave mirror, the image formed is a real and inverted. Real means you can touch and see. Okay, so the virtual image is formed by the when the concave mirror is used, the real image is formed, and if the distance is far, the distance is more, then the real and inverted image is formed, but when it is close, the virtual image is formed. So here in this we can see the virtual image is formed because it is very close to the concave. The object is close to the concave mirror. Now how this concave mirror is useful? These concave mirrors are used in, you must have seen the dentist use the concave mirror. They are used in reflector in headlights of scooter, car, railway engine, searchlight. The dentist also uses concave mirror to see an enlarged image of teeth while examining the teeth. The doctors use concave mirror for examining eyes, ears, nose and throat. They are also used in shaving and makeup mirrors. So the next one we'll see is the convex mirror. Now how the images are formed in the convex mirror. Take a convex mirror on a stand and place it on the table. Keep the lighted candle 40 cm from the convex mirror. Observe the image of the candle formed behind the mirror. Now move the candle towards the mirror and place it at different distances from it and obtain the image in the mirror. Now the image formed by a convex mirror is always erect. In this picture you can see the image is formed behind that screen. Erect, virtual and smaller than the object. When the object moves very close to the convex mirror, the size of the image increases slightly but never become equal to or more than the size of the object. So now, what are the uses of the convex mirror? The convex mirror is always used as the rear view mirror or side mirror in vehicles. They are used as staircase mirrors on the double-decker buses. So why these convex mirrors are used in the... This is because they are because they form the small images and give the spread over the larger area. So these help the drivers to see the traffic behind them. Now let's talk about the lenses. So what is meant by lens? You might have seen a magnifying glass. It is used to read very small print. You might have also used it to observe the body parts of the cockroach or an earthworm. The magnifying glass is actually a type of lens. The lens is a piece of glass through which we can see. Those lenses which, if you touch and see, those lenses which feel thicker in the middle than at the edges are convex lens. See here you can see the middle portion of the picture A is more than the edges. So those which feel thinner in the middle than at the edges are concave lenses. Notice that the lenses are transparent and light can pass through them. Now the next one, if you see, the convex lens converges the light generally falling on it. Therefore, it is called converging lens. On the other hand, a concave lens diverges on the light and so it is called the diverging lenses. Now, what are the uses of this convex lens and the concave lens? Convex lens is used as a magnifying glass. It is used in telescope and binoculars to see distant objects. They are used in spectacles to correct far-sightedness, that is, to see nearby objects clearly. Now, the concave lens, they are used to correct short-sightedness, that means to see distant objects clearly. They are used in telescope also. Now, the next one is, you have seen the rainbow in the sky. You might have noticed that it appears usually after the rain when the sun is low in the sky. How the rainbow is formed? Generally, after rain in the morning and evening, the rainbow appears in the sky. It appears as a large arc in the sky having many colors. It is a natural phenomenon. It is a phenomenon of reflection, refraction, and dispersion of the light. So when the light is dispersed, that means it's separated, we have the 7 colors. That is red, orange, yellow, green, blue, indigo, and violet. So here in this picture, the light is dispersed by the sunlight is dispersed by the glass prism. Means here there is a glass piece is used to separate the light. So the sunlight has 7 colors. We can shortly say Vibgyor, Vibgyor, Vibgyor we can say. So the colors, when you are writing, you should write in order. Now, you might have seen that when you blow soap bubbles, they appear colorful. Similarly, when light is reflected from the surface of the compact disc, you see many colors. On the basis of these experiences, we can say the sunlight is made up of 7 colors. So that one we can split by means of the glass prism. Now, take a circular cardboard disc of about 10 cm diameter. Divide this disc into 7 segments. Paint the 7 rainbow colors on these segments. You can also paste color papers on these segments. Make a small hole at the center of the disc. Fix the discs loosely on the tip of the refill of the ball pen. Ensure that the disc rotates freely. Rotate the disc in the daylight. When the disc is rotated fast, the colors get mixed together and the disc appears to be whitish. Such a disc is popularly known as Newton's disc. So what we have learned from this means the light has 7 colors. We can split with the help of the prism. Otherwise, you can make the white color with the help of when it is rotated. So what other points you have learned? The real image and the virtual image. Real image means the image can be obtained on the screen. Virtual image, it cannot be obtained on the screen. So this real image always inverted. This virtual image is always erect. Then we have studied the differences between concave mirror and the convex mirror. Concave mirror, its inner surface is shiny. Convex mirror, its outer surface is shiny. Now convex lens, it feels thicker in the middle than at the edges. Concave lens, it feels thinner in the middle than at the edges. So both the mirrors and the lenses are very much useful in our day-to-day life. Thank you. Read the lesson and do the textbook exercises.